Today we're going to look at a type of series, and it's actually going to be pretty nice because this might be the first time you look at a series and think, hey, this is actually pretty easy. So what kind of series am I talking about? Well, what we're going to do, we're going to look at something that we've dealt with before, right? Something we've dealt with is the sum from n equals 1 to infinity of 1 over n squared, right? We did this in the integral test video and showed that this is a series that converges, right? But here's what we want to do with this whole p series thing. We want to look at, we can see that our function is 1 over n to a power, right? Our power in this case is 2, right? Now there's this series called the harmonic series, and it looks a little something like this. It looks like the sum from n equals 1 to infinity of 1 over n. Now, you can see these are very similar series. The only thing that changes is the power that n is raised to. You see in this one right here, n is to the first power, and right here, n is to the second power. Now, what do we do when we have some kind of format like this? When we have a sum where it just follows this trend of 1 over n to some power. Well, let's say we do have something like that. Let's say our sum is the sum from n equals 1 to infinity of 1 over n to some power p, right? We can say that this series is going to converge. We'll say converges, the series converges if p is greater than 1. However, it diverges if p is less than or equal to 1. So with this logic in mind, our harmonic series right here, 1 over n to the first power, our p is less than or equal to 1. So we can say that the series will diverge. Whereas with our series up here, which we showed in the divergence or in the integral test video, that this series does converge, we can also just use p series. We could tell, since we just have 1 over n to the p, and in this case p is 2, which is greater than 1, our series is going to converge. Now, let's look at some other kind of example real quick, because this is a little bit too easy. Let's say we were given something like this. Let's say we had 1 over, we had 1 over the square root of 2 plus 1 over the square root of 3 plus 1 over the square root of 4, ... You see the pattern going on here, and we want to know, is this series going to converge? Is it going to diverge? Well, we can use p series, right? At this point, if you didn't know, if you're taking the square root of something, you're essentially raising it to the 1/2 power. So this series is equivalent to 1 over 2 to the 1/2 power, plus 1 over 3 to the 1/2 power, plus 1 over 4 to the 1/2 power, and so on, right? And now it's looking like we have something like our p series, right? This series that we're writing looks like the sum from n equals 2, in this case we started at n equals 2, to infinity of 1 over n to the 1/2 power. And based on what we just learned, p, in this case, p is equal to 2. P is equal to 1 over 2, 1/2, which is less than or equal to 1. So our series, we will say, diverges by the p series. So like I just said 3 minutes ago, people like the p series because this is a very simple way of telling if our series converges and diverges. And yeah, that is all there is to it. So if you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.